It's not investigate. Okay, good evening, everyone. So we are starting our lesson. So if you join us, you can just type up your name so that we see who is with us. So type up your name as we begin. You can type up your name as we are starting. We are going to do what we call the redox. So redox reaction, meaning you're going to focus on balancing redox reactions in acidic and the basic medium. So this will be our focus for today. So if you're able to get me, just type up that you're able to get me so that we can start. So type up if you're able to get me so that we can start. Okay, Enoch. Okay. So you can type up your name, and if you're able to get me, just say I'm audible enough so that we can proceed. Okay, so if you can get me, just type up your name. And let me know if you're able to get me so that we can start. Yeah. Okay. So we are starting. So in class, you remember we we basically, so this one is aqueous solution. The topic is basically aqueous solution. So we are doing aqueous solution. And then the concept we're focusing on today is balancing of redox reaction in both acidic and basic medium. If you remember very well in class, we basically talked about this. We did how to balance in acidic medium. So what was left is how to balance in basic medium. But now for the sake of clarity, we're going to do a quick revision on how we did it in terms of balancing in acidic medium. After that, we'll proceed to basic medium. Like I told you that the sequence of balancing redox reaction also move like this. So if you want to balance that, first you have to balance in acidic, then you can proceed to basic. So meaning that you cannot balance a reaction in basic medium without balancing in acidic medium. So meaning, even if the question comes to say balance in acidic basic medium, first you should balance in acidic. After that, you proceed to that. So that's why our today's focus is to understand how to balance in basic medium. But because for you to balance in basic medium, you first need to balance in acidic medium. So we're going to do a quick revision about everything that we covered last time when we met. Okay, so let's begin. So we know that we are talking about redox reaction. So if you think of the word redox, we say that redox is made up of two words. We have the word red and the ox. So the word red means that reaction, reaction. And then ox basically mean oxidation reaction. So we can know that reduction, the word redox made up of two words, reduction and oxidation reactions. Then we abbreviate as redox. So redox is a short form of reduction oxidation of reaction, reduction oxidation reaction. So in short form, we just say redox. Okay, yeah, so let's start. So we are saying that today we are going to do this. So first thing we should understand the same concept, redox. So we have to focus in on reduction first. We understand what is reduction it's by definition. So reduction, I've got 4 definitions. We said that this one I've got 4 definitions, 2 important and 2 useless definitions. So first we begin with the first 2 important definition of the word reduction. So the 2 important definitions. So the 2 important definitions of reduction, that's number 1. Reduction is the decrease in oxidation number. So I will basically define what an oxidation number is in the meantime, but we know that reduction can be defined as a decrease in oxidation number. Then number 2, we can say reduction is the gain of electrons. So these are the first 2 important definitions of reduction. So for the useless one, you can check from the documents. Do we just focus on what is important for what I'm going to cover? Okay, so reduction can be defined as a decrease in oxidation number or decrease in oxidation number or the gain of electrons. But now we may ask, what is oxidation? So now we come to the other guy, oxidation reaction. So oxidation, the first 2 important definition we can say it's the opposite of the other 2 here. So oxidation is this one was a decrease in oxidation number. So in this case, to be defined as the increase in oxidation number. So I'll explain about oxidation number in the meantime. Then the other important definition is that oxidation is the loss of electrons. So this is what we did, loss of electrons. So this is just a quick revision from what we covered last time when we did this. Yeah. Okay, so these are important definitions. So you should know this, that reduction can be defined as increase in oxidation number or gain of electrons. Then the other one for oxidation is the first one could be an increase in oxidation number or loss of electrons. So these definitions, they are very, very important in terms of balancing of redox reaction. If you don't know the definition, you face a challenge on how to balance them. So make sure you master the 2 definitions. So now I want to make you understand the concept of what do we mean when we say oxidation number before we proceed. Okay, so let's focus on the oxidation number. So oxidation number is also called oxidation state. So it can be so called oxidation state. So oxidation number is also called oxidation state. So what is it by definition? So we can define that this one is a charge indicated on the, you can say, top of an element or compound. So for example, if I write this one NH4, this is ammonium. Ammonium will got a charge of positive here, meaning it's a positive one. So meaning the oxidation number of ammonium is basically positive 1. So when you say oxidation number or oxidation state, we mean the charge which is found on top of the element. For example, I can also give you maybe sodium ion. We have a +1 there, meaning this is the oxidation number of sodium ion is positive 1. The other thing I can give you, like if I say chloride ion with a -1 on top, meaning oxidation number here is also the -1. Other thing I can give you, maybe it could be, let's say we give you magnesium 2+. We have a charge of 2 here, meaning that's the oxidation number. The other thing I can give you is like, maybe let's say we bring in maybe ammonia. Ammonia have got no charge on top of it, meaning the oxidation number is 0. So oxidation number in simple term is a charge that is indicated on top of an element or a compound. So if it's nothing indicated on top, meaning the oxidation number is 0. For example, if I just say write potassium here, I haven't indicated anything on top of it, meaning the oxidation number for this one will be 0. But I will show you how we calculate this so that we get to understand. But for now, I want you to understand the definition that when we say oxidation number, we simply mean the charge that is indicated on top of a compound or element, like I've shown you examples here. And another thing we should understand, that an element where there is no charge indicated on top, it shows that that's the oxidation number of that element is basically, or compound is a 0 in that case. So just know the definition for now before we proceed. Okay, so let's proceed now. Let's go to the next concept. Okay, hopefully you're able to get me. So if you're able to get me, just type up that yes. Then I will know that you're getting me. So far we have covered what is reduction reaction, what is oxidation reaction, then what is an oxidation number or oxidation state. So I've covered 3 concepts. So now let's go to the next one now. Now that you know what an oxidation number is, so let's proceed to see how do we calculate oxidation numbers of elements or specific compound or element in a particular compound. So the question is how to assign oxidation numbers of elements. Okay, good. So how to assign, so the question is how to assign oxidation numbers of elements or compounds. So basically, to do this, there are some rules that we need to understand, because we said that I can give you an example. For example, let's bring maybe let's say potassium dichromate. Okay, this is even like this. Yeah. So in the exam, they can ask you that, can you determine the oxidation number for chromium in potassium dichromate? So now the question, how can you calculate for this? So that's the concept we want to build. Okay, good. So how can you calculate for this? So now let's understand what rules a student should know for you to be able to respond to such questions. So we are saying now we focus on the rules to follow when when assigning oxidation.
Dr. Bob.
Mwevo.
Nasema mwive wino ka?
Yes, yes.
No, I found it.
Rules to follow when assigning oxidation number of a particular element. So what rules do we follow? So we are going to start now the rules. Rule number 1 is that very simple, that an element in a neutral state or natural state, or we can say neutral state, the oxidation number is 0. So let's write in brackets 0. So it's 0. For example, we say an element in its natural state, the oxidation number is 0. For example, if I bring and I just write, let's say sodium here, I haven't indicated any charge on top, meaning this is sodium element in the neutral state. It hasn't reacted with anything. It hasn't lost any electrons. So meaning its oxidation number will be 0. Other one I can give, it could be maybe same, that one, no charge on top, meaning it's a 0. The other one we can bring in that, okay, let's say maybe go for non-metal. Just maybe we pick maybe chlorine like that, or maybe fluorine. Anything like what we have here, these are elements in their neutral state. They haven't reacted with anything. So meaning their oxidation numbers are zeros. So if in the exam they ask you, they just give you an element alone like this, an element standing alone, and then nothing has been indicated on top, either a positive or a negative. Just know that automatically the oxidation number of this one is a 0. So this is the rule number 1. Then rule number 2 is that all elements from group 1. So we need to have a good understanding of periodic table. No wonder we did periodic table together in Introduction to Chemistry. So say all elements from group 1 have oxidation number of positive 1, condition that when they are present in a compound. So we say all elements from group 1 have oxidation number of positive 1 when they are present in a particular compound. So this is very simple. We should understand that group 1 elements, they react with other elements by losing 1 electron. We know that, right? So meaning that the number of electrons an element is losing or gaining when they react is basically equivalent to the oxidation number. So we should know that group 1 elements, when they are present in a particular compound, they have oxidation number of 1. So let's make a difference here. We have sodium here. It was alone, not in a particular compound. No wonder it was a 0, because it was in a neutral state. It hasn't reacted yet. But the moment it reacts, it will be present in a particular compound. For example, we can have, like I gave you potassium to dichromate. Remember I gave you this one. We have potassium here. It's from group 1. So we should put it in mind that this is potassium. It's from group 1. And at the same time, it is present in a compound. So meaning the oxidation number is positive 1 for potassium here. So this is very, very important. Another one can be maybe, let's say, just potassium chloride like this one. This is a compound as well. So meaning potassium here will be the same. Or maybe you can say sodium chloride. Sodium is from group 1. So meaning that this one now is present in this compound. We should know that the oxidation number for sodium is going to be a positive 1. So this is very, very important also to take note of. Yeah, so after this, let's go to the third rule that you need to understand, that the rule number 3 is that again all group 2 elements have oxidation numbers of positive 2 also when they are basically present in a compound or molecule. Okay, so all group 2 elements, same concept with group 1, but for them since they are in group 2, meaning they have got oxidation number of positive 2. For example, if I give you maybe magnesium chloride, we should know that magnesium is a group 2 element. It's present in a particular compound. Its oxidation number is positive 2. Simple as that. Okay, now we go to number 4. Number 4 is that again all group 7 elements. So group 7 element, we know them. Those chlorine, fluorine, bromide, iodine, D, and all that, all group 7 elements. Also, they have oxidation number of -1. Again, same way when they are basically present in a compound or molecule. So same concept with the same. So we know that it's a simple way to remember. We know that group 7 elements, when they react with another element, they gain 1 electron, and the tendency of gaining electron attracts negative charge. So when an element gains electron, its charge drops. So chlorine initially, it's like this, I've got no charge, the charge is 0. But after it reacts with anything, it goes to chloride ion with a negative on top. I mean, this -1 on top will indicate the oxidation number of chlorine in this case. Okay, so now let's go to number 5. So number 5 is that oxidation number of oxygen is always -2. But here is an exception. So whenever you see oxygen in the particular compound, we know that the oxidation number is -2. So just exception that we have with that. Except in hydrogen peroxide. So this is hydrogen. So you should know how to differentiate water molecule and hydrogen peroxide. Water is like this one here. But hydrogen peroxide, we have a 2 oxygen as well. So 2 both. We have a 2 here, 2 here, but this is water. So we should know that oxidation number of oxygen is always -2, except when this oxygen is in hydrogen peroxide. So in hydrogen peroxide, it is a -1. So take this serious, very, very important, that oxidation number of oxygen is always -2, regardless whichever compound the oxygen appear into. So you can find oxygen in any compound, or molecule, just know that the oxidation number is -2 for that oxygen there. Now, the only exception that you should put at the back of your mind, that when oxygen is present in hydrogen peroxide, its oxidation number becomes -1. Okay, so are we together? So just type up if you are following me closely, so that we can proceed. Okay, so are we together? Okay, so all right. we can proceed. So we have done how many? 5. So now let's go to the number 6. We do number 6 now. So we have done group 1, 2 element oxidation number +2, group 7 -1, then oxygen is always -2. So it's very simple to know. Very, very simple. Very, very simple. Okay, so if you're following me, basically just type up yes, so that I can proceed. Okay, good. So powerful. Let's proceed. Yeah, so now we go to the rule number 6. So rule number 6 is about hydrogen. We should know that oxidation number for hydrogen is always +1. Okay, oxidation number for hydrogen is always positive. We don't even need to calculate for it. Whenever we see hydrogen, just know that oxidation number is basically a +1. We don't calculate. But now we also have an exception. So exception for this one, very, very important exception. Exception is that when hydrogen is present in a binary. So we did this from term 1, binary, or topic 1, which is intro, binary ionic compound. So we know the word binary, I've got 2 words. There is a word bi and nari. Okay, so bi means 2, nari means number. Okay, so same binary operation in math, meaning we are dealing with 2 numbers only. So we are saying that the oxidation number for hydrogen is always +1 when it is present in any compound. So whenever we see hydrogen in any compound, the oxidation number is +1. We only have one exception. So except when hydrogen is present in a binary ionic compound. So a binary ionic, what is binary ionic compound? So binary ionic compound is a reaction between a metal and a non-metal. And in that particular reaction, there are only 2 elements. Like for example, if I give you, let's say, sodium hydride, this is binary ionic. We only have 2 elements. So bi means 2, meaning that compound, only 2 elements are present, which is hydrogen and any other metal. So when hydrogen react with any metal, okay, so whenever hydrogen react with any metal, hydrogen act like a non-metal and gain an electron and get the charge of negative. So what I want you to understand is this: when hydrogen react with a non-metal, it act like a metal and lose an electron, become a positive charge. But when hydrogen react with a metal, it behaves like a non-metal and gain an electron from a metal. So we're saying that except when this hydrogen react with any metal, and in that reaction we only have 2 elements, that is hydrogen and that metal. In that case, this one we call it binary ionic compound. So in that case, the oxidation number of hydrogen won't be +1, but it will be -1. Okay, so what I'm saying is that the oxidation number of hydrogen is always +1, except when hydrogen react with any metal, and in that particular reaction we only have 2 elements, hydrogen and that metal. In that case, the oxidation number of hydrogen will be -1. Reason is simple. So what you should understand that when hydrogen react with a metal, it behaves like a non-metal and gain an electron. And whenever an element gains electron, it becomes negative charge. So that's the case. The reason why you are saying that here. So hopefully now we have gotten the concept about this one, and no one is behind. We have understood that oxidation number of hydrogen in any compound is basically negative, positive one, except in binary ionic, meaning ionic compound is the reaction between metal and non-metal. Okay, so we should basically know that if I give you water like this, we have two elements here, hydrogen and oxygen, but they are all non-metal. This is not binary ionic, it's binary covalent, meaning this one hydrogen will maintain the same positive one. Okay, but only if hydrogen react with a metal. But here hydrogen is reacting with a non-metal, meaning this is not ionic reaction, it's covalent reaction. Okay, so only in binary ionic. Yeah, so if we are together on this point, allow me to proceed. If this concept is clear to each one of you, let's proceed to the next concept, which is the last important rule. Okay, so so number 7, the last one, that the charge indicated on top of the, could be the element or compound, is equal to the overall oxidation numbers of all the elements. Okay, all the elements in that compound. Okay, all the elements in that. So what you're saying that the charge indicated on top of the element or a compound is equal to the overall charge or the overall oxidation number of all the elements present in that compound. For example, if I give you that, let's say ammonia, then here we can give you ammonia. The other one, maybe let's, which one can we get from here? Okay, maybe this one. Yeah, like that. So another one, maybe another one. Let's say, okay, my favorite one here. Okay, my favorite one. So we are saying these are compounds. The other one we can give is, okay, just is fine. The other one we can give, okay, maybe the last one. Let's okay, let's say A, B, C, D, and then E. Let's look at okay, sodium plus. Yeah. So we are saying that the charge indicated on top of the element or a compound is equal to the overall oxidation number of all the elements present in that reaction. So if we think of our ammonium here, what is the charge indicated on top? Can someone type up, please? What is the overall charge, the charge indicated on top of ammonium? What's the charge indicated on top of ammonium? Type up quickly. What is the charge indicated on top of ammonium there? So ammonium is here in case you don't know ammonium, because some of you act like you don't see. Can't you just don't know? Yeah. So it's positive 1, good. So meaning that if I bring ammonium here, ammonium have got two elements here. There is nitrogen and 4 hydrogens. So meaning that if we were to add oxidation number for nitrogen plus that of oxygen, but that of hydrogen, the final answer is +1. Meaning if we add, what is the oxidation number for nitrogen here and oxygen and hydrogen, sorry, the overall charge is +1. So meaning summation of the oxidation number of all the elements within ammonium, the sum total is +1. For example, if you have got set A here, we add all the elements that is here. Maybe we have potassium element, we have sodium, whatever element, oxygen, then sum total if it is +1, meaning this is the overall oxidation number. So if we sum, whenever we see an element like this one, the charge they indicate on top, meaning they added the oxidation numbers of all the elements in that particular compound, and then the overall charge is what they put on top here. So this is important in terms of calculation. If you don't know these 7 rules I've told you, then you face a challenge. So +1. So that's a writing one. Me, I always want students to say positive to indicate the charge. Is it -1 or +1? So it's +1. Good. Yeah. So now let's do some examples. Remember, our main thing was that how to assign oxidation numbers of elements in the compound. Then we proceed to focus on the rules that we follow. So now I have shown you the rules that we follow. Now let's do a quick example so that we can proceed to something different. So here is that how to assign. So now my question that, so let's say question here. This is an exam question I'm giving you here, okay? Assign oxidation numbers of the following indicated the elements. So A, let's pick the same ammonium here. So the element I'm going to underline is the one we need to find. So we need to get for ammonium, for nitrogen. Then B, let's go for my favorite one, 9. Okay. So potassium dichromate. So no, we check for chromium. So sorry for that. We check for not for chromium. Good. Then let's say C. Let's check for which one? Okay, the same one here. The same thing we did. Then we need to check for sulfur. Then last one, so that we proceed first B, C, D. Okay, let's just simply say 2 plus there. Yeah. So we need to calculate to assign oxidation numbers of the underlined elements. So the first one we have is solutions. So we need just to use the rules that I showed you. I have basically outlined to you. So the first one is ammonium here. So you remember, you guys, let's just do something, a quick one. For example, if I say x plus y is equal to 3, then when x is 1, then question is find y. This is simple math, right? We know this. Meaning that what we do is that I have got x plus y. Answer is 3. But I know that my x is 1. How can I find y? So we need to replace x with a 1, then solve for y. So going to this is 1 plus y equal to 3. Okay, now how can you find y? Is to collect like terms. So 1 can go there, which means y is equal to 3 minus 1, meaning y is what? +2. Yeah, so this is simple math. So the same thing we are going to do here to find for nitrogen, because we already have information about hydrogen. We know that oxidation number of hydrogen is always a positive 1 when hydrogen is present in any compound or molecule, except in the binary ionic compound where it is a negative 1. So what we do here that we have an overall charge of positive 1, meaning that if we add, like here we say, if we add x and y, we are getting 3. Knowing that x is 1, how can we find y? Is to replace x with a 1 and then so for y. Same here, meaning that if we add nitrogen plus 4 hydrogen, some hydrogen therefore if you check out here, the answer is positive 1, which is on top there. But we already have information about hydrogen, that the oxidation number of hydrogen is always a positive 1, except if it is present in a binary ionic compound. And this is not binary ionic, but binary covalent, because hydrogen is reacting with a non-metal. Okay, so what we do here that we don't know for nitrogen, but we have 4 hydrogen, and we know that the oxidation number for hydrogen is positive 1, which will be equal to positive 1 as the overall charge. So the positive I'm putting in bracket here is the oxidation number for hydrogen. The positive I'm putting here is the overall charge that we have on top there. Okay, so now we say, okay, this will be n plus 4 equal to positive 1. Then we can collect like term like we did here. We collected like term. So even here going to collect the like terms. So n will be equal to 1 minus 4, meaning nitrogen is basically negative 3. So you should have calculated, simple as that. So this concept will be needed when balancing in redox reaction. Very, very important concept. Yeah, if we don't know this, you won't balance. So we have answered the first question in the example A. So let's go for B1. Okay, so we go for part B. Yeah, so let's go for B. So B is basically simple as well. We say potassium dichromate. So they want us to find for chromium. So if we check, we don't have any charge. We say that the charge indicated on top of the element or a compound is equal to the overall charge or the overall oxidation numbers of all the, meaning summation of all the oxidation numbers of all the elements present here is the charge that I indicate on top. But since we don't have any charge here, meaning that if we are to add everything here, it's giving at a 0. So meaning that we have 2 potassium here plus 2 chromium again plus 7 oxygen. Answer should be a 0. In the same case where we had this for the X, answer was 3, but in this case it's a 0 overall charge. So now we have to think, what information do I have about potassium? We know potassium is a group 1 element, and we see that when a group 1 element is present in any compound or molecule, its oxidation number is positive 1. So we can say this could be that we replace with the positive 1 there. Let's say plus 2 chromium. This is the one what they want us to calculate. So plus 7. Then what do you know about oxygen? We know that oxygen, the oxidation number for oxygen is always negative 1, except in what? Hydrogen peroxide. So then you replace negative 2 here. This is equal to 0. So what is 2 times 1? We get 2 plus 2Cr. Then 7 multiplied by negative 2, we get negative 14 equal to 0. So we can say this is 2 minus 14 plus 2Cr equal to 0. So this is negative 12 plus 2Cr equal to 0. And then like terms. So this is the 2Cr equal to positive 12 over 2 over 2, meaning our Cr is positive 6. So I've calculated. So these are the concepts you should basically know. It's very simple, not even that. Not even the way you can imagine. Very, very simple. So this is how we assign oxidation numbers. They ask in exam this, and it's coming. So let's go to the other one we had is sulfur. So we go for number C, sulfate. Yeah. So for sulfate, they want us to assign for sulfur. So they always tell you what to assign in the question in the year. So here we're going to do this. The overall charge is positive 2, right? So we're going to say that S, which is 1 sulfur here plus 4 oxygens, overall charge should be negative 2. Now we have to check. What do I know about sulfur? Okay, the one they want me to find. What do you know about oxygen? We know that oxygen oxidation number is always negative 1. Oh, sorry, negative 2, except in hydrogen peroxide where it is negative 1. So I say, okay, sulfur plus 4, then minus 1 here is equal to negative 2. The sulfur minus 4 is equal to negative 2. Then this is equal to negative 2 plus 4, right? So meaning sulfur is what here? Oh, sorry, negative 2 here. Sorry, I made a mistake. It has to be 80. Okay, let's just do this from this side. We say sulfur plus 4 oxygen equal to negative 2, meaning sulfur plus 4 negative 2. Okay, good. Then negative 2 there, meaning sulfur minus 8 equal to negative 2, meaning sulfur is equal to negative 2 plus 8, meaning positive 6. Okay, so that's how we assign. Very, very simple. Yeah, so hopefully no one is behind up to this point. Okay, good. Thank you for that quick observation from Jerome. Okay, yeah, so let's now do the last one, which is very basic. D, we have magnesium ion. So this is just a standing alone element with a positive 2 on top, meaning it's a direct positive 2. We don't need it to write because it's alone and with a 2 on top. It's the same way if I can give you, let's say, potassium with nothing on top, it's automatic 0. So this is the base concept in and how we assign oxidation number. We did this in class, if you remember very well. It was just a quick revision to make sure that in case there's someone who is attending this for the first time, so that they can have the background of what we'll be doing in the next few minutes. Okay. Yeah, so we started at 20, 30 somewhere there. 21:11. Okay, so let's proceed to the next concept now. So anyone with question, are we together so that we proceed? Just type up yes, so that because now we are changing the concept from this to the next level. We are trying to build up. So are we together so far before I proceed? So are we together before I proceed? Okay, so we need to solve more questions today, like these ones here. So are we together? Just say yes in simple terms so that we can start the new concept. Those with network issues, what do you stay? Kuchipata compound. Fine. Yeah. So we are together. Okay. Yeah. I've seen some response there. Okay, good. So far, so good. Okay, good. Ruth. Yeah. So, okay, let's now proceed to the next concept. Yeah. Okay. So now, remember our main thing was that we need to do balancing of redox reaction. So that was the main case. But we can't go for balancing without this concept. So we said that our main thing was balancing, you remember. Balancing of redox reaction in acidic and basic medium. Okay. This was the main thing we are here today. But we can't start this before without you having that information that we have covered. It was very important for whatever you're going to do here. So first thing, I want you to understand that process of balancing goes like this. First, it is acidic, then we can balance for basic. So there is no way you can balance in basic without balancing acidic. So basic the first one, then we go to acidic. That's how the information flow. So first we did this in class, which is the acidic medium. But for the sake of clarity and understanding, we are going to do a quick revision about this so that we proceed. And this one is very, very simple. This is the hard one here, but it's understandable anyway. So we're going to say that step one. So write even whenever you are, write balancing in acidic medium. So this is the concept. Balancing redox reaction in acidic medium. Okay, so we all know that first thing, let's try to define what an acid is. So what is an acid? So now an acid is a compound that basically produces hydrogen ions when dissolved dissolved in water. So just write H2O when dissolved in water as the only positive charge. So we know that an acid is a compound that when dissolved in water, it produces hydrogen ion as the only positively charged. Okay, so when balancing in acidic medium, the moment as you are balancing the steps, the moment hydrogen ion appears in your reaction, meaning that you have balanced. But anyway, let's just try to see the step that we should do. Should know what to follow. So before I go in further, let me just do this. Main thing to balance. So main things to balance. So number one, we need to balance all the elements. We also need to balance hydrogen. We also need to balance oxygen, as we are going to see. Then number 4, we need to balance electrons. So these are the main things that you need to balance when you're dealing with the stuff. All the elements, hydrogen, oxygen, and the electrons. But anyway, let's just focus on the rules, which are very, very important. Okay, so we are saying that balancing in acidic medium. So rule number 1. So we're talking about the rules to follow. What rules do we follow? So we're talking about here the rules. So rule number 1 is that assign, like from the previous thing we have been doing, assign oxidation numbers of all the elements except oxygen and so we cannot assign for oxygen and hydrogen because this one they are known, they are always -1. So I say assign oxidation numbers of all the elements except oxygen and hydrogen. Then number 2 is that identify, after we assign oxidation, next is to, this is very, very important, set 10 to 15 marks in the exam here. So this concept is very, very important. Make sure you understand it at all, so that you don't get stuck in your tests and exams. Very, very important. Like I always tell you that if you have time to do something, like we are in school, and then you know why you came here and all that. So if you have time and you know what to do to pass the exam, better you do that. So you know that for you to pass, you need to study. So study and pass. Yeah. So let's proceed. So after that, let's go now talk about the second one. So it's assign oxidation number 2. Identify which reaction is what is there. 1, oxidation half. So reaction, I'll be writing Rx. Rx means reaction. And also number 2, which reaction is the reduction. Reduction half reaction. So step 1, we assign oxidation numbers. Number 2, we identify which reaction is reduction and which one is oxidation. So to go for number 2, this is where now the definitions of reduction and oxidation become important, because for step 2 we use definition to identify. Okay, remember what we said. The reduction is the decrease in oxidation number or gain of electrons. Then oxidation is basically increase in oxidation number or loss of electrons. So those definitions are the one we'll be using to help us identifying at stage 2. So now when we identify, we move to step 3. So we assign, we identify. Then number 3, we balance. We need to balance. So now balance all the elements except, very, very important here, except oxygen and hydrogen. Okay, so balance all the elements except oxygen and hydrogen. Yeah, for example, if I have let's say we had let me just give an example that can make you understand what you're talking about. Assume we have, okay, anything we can have. Let's say we have sodium hydroxide plus maybe, let's say, okay, anything maybe, okay, like this. Then we are getting okay, anything we can have, like maybe, okay, sodium chloride plus, this is very complicated. Let's just say we have A plus B. This is oxygen 9. Then we are getting AB, for example, like this. Yeah. So we can't balance oxygen. Then let's say maybe plus let's say plus what? Okay, plus water. Commonly, this is just a formed thing here. I just want to make you understand this. So we have hydrogen here. We can't balance hydrogen, but we can balance A, B, and C. So we have 2B here, 1A. So I have to put a 2 there so that we get 2. And then you also put, since you have 2A, you also put a 2 here. Meaning we have 2A, and 2A, 2B, 2B. We don't care about hydrogen and oxygen, how many they are. We don't balance them using numbers. We just balance all these other elements except oxygen and hydrogen. So this is the concept, but we are going to see the reality of this in the actual equation that we are going to start solving. So after this, we are saying balance all the elements except oxygen and hydrogen. So I assign oxidation number, identify which one is reduction, half reaction, and oxidation. We are using definitions. Then balance all elements except oxygen and hydrogen. Okay, so now let's go to number 4. Okay, so we are together in. So let's go to number 4. So number 4 is that we need to balance oxygen using appropriate number of, yes, can someone finish the statement? Balance oxygen using appropriate number of what? Quickly, can someone type up? Quickly. What do we use to balance oxygen? So balance oxygen using what? Okay, I'm waiting for the answer. What do we use to balance oxygen? Addition, fast, quickly. Yeah, what do we use to balance oxygen? Okay, water molecules. Okay, good. These people are studying. Eh? So we balance oxygen using appropriate numbers of basically water. Yeah, water molecules. So water molecules, H2O, whatever it is. Yeah, so that's the case. Next, let's go quickly, just and then we're going to revise them. Number 5. So these people can study. Then balance again. After that, we need to balance hydrogen. Using appropriate. So where the appropriate means equal number of water molecules and all that. Appropriate number of what? Balance hydrogen using appropriate number. Appropriate number of what? What do we use to balance hydrogen? We use water and then use hydrogen. Okay, good. So we use hydrogen ion. Appropriate number of hydrogen ion. So we should. This is hydrogen ion. It have got a plus on top. This is just hydrogen element without any charge on top. When you put a charge on top, meaning this is hydrogen ion. If you don't put a charge, just an element. Yeah, hydrogen element. So this is what you need to know. So we assign oxidation numbers. We identify which one is a reduction, which one is the oxidation of reaction. Number 3, we have to balance all the elements except oxygen and hydrogen. Number 4, we have to balance oxygen using water molecule. Number 5, we need to balance hydrogen using hydrogen ion. Now 6 that we have to calculate the number of electrons lost and gained in each half reaction. So let's say calculate the number of electrons lost in reduction half reaction, then at the same time, and also the number of electrons gained in what? Reduction. Okay, reduction half half reaction. Remember what we said that we said that why is so yeah, sorry, in oxidation. Okay, so calculate the number of electron lost in oxidation half reaction and also the number of electrons gained in reduction half reaction. Remember what we said, oxidation is the loss of electrons. So we have to calculate how many electrons was lost in that particular reaction. At the same time, reduction is a gain of electrons. So you need to calculate the number of electrons that was gained in that particular half reaction. So you need to know the actual number of electrons. Okay. So let's move to the next concept, which is be number 7, is that we should know that for the reduction half reaction, number of electrons gained are added to the reactant side. For example, if the reaction was A plus B, maybe you're getting C. Let's assume it's like that. The number of electrons lost, maybe gained, was 2 electrons. So this electron has to be added here to the reactant side. So for me, the way I used to remember this is like this. So let's read this. For the reduction half reaction, number of electrons gained are added to the reactant side. So this is like for the reduction half reaction, electrons are added to the reactant side. So I used to do it like this. If we write the word reduction and the reactant, they all start with R. So this has to tell that for the reduction half reaction, number of electrons gained are added to the reactant side. So R. Okay. Meaning that for the oxidation half reaction, electrons are added to the product side. So if you know one, you know the other, to the product side. Okay. So this is what we should know, that the reduction and also the electron gained in reduction half reaction. Now, what do we do with them? What are these electrons for? So we should know that for the reduction here, we have reduction and oxidation half reaction. We have two half reactions, reduction and oxidation. In the reduction, when we calculate the electron that was gained, we add them to the product, to the reactant side, okay? But for the oxidation half reaction, when we calculate the electron that was lost, we add them to the product side. So I'm saying this is what we do, okay? So after this, now we can proceed to the last one, which will be, I think, number 8. So that add the two half reaction and cancel out spectators ions. So that will be number 8, right? So 8 will be that add the two half reactions and cancel out what is common in short time. What is common? We mean, when you say what is common, we mean what is appearing to both sides of the equation, meaning the reactant side and to the product side. So these are some of the basic steps that you need to understand before we can go for anything that for an example. So let's do a quick example, which is an exam-based question, and then we can end. So we are on the last part of the today's session. Okay, 21:34. So it's approximately 1 hour from the time we started. Okay. So are we together? We proceed. So let's do an exam question. So let me just find the question here. I think I have one. So if you check, we have questions here. If you're able to see, yeah. So we have questions here. There is one here, which is question what? There is question B here, balance the redox reaction in acidic medium. So this reaction, it was 8 marks. So a sessional exam. Yes, they reduce marks in session. So 8 marks. Then there is this one here, the beautiful one. Given the reaction is here, so the marks was how many? This is 1, 2, 3, 4. 4 by 4, that's 16 marks everything. So it was 16 marks just to balance in acidic medium. 16 marks here and all that. So this was test 1. Then this was sessional question there. So we are going to do this same one, the sessional question here. But we are going to end on basic, on acidic here. But it was going to balance in the basic medium. So that's the question I'm going to solve. Let me just type up here so that you see it properly. So we say this is an exam question. So the question is that balance the redox reaction in acidic medium. So the reaction is MnO4 minus plus I minus on top. We are getting Mn, which is manganese, O2 plus I2. Yeah, so this is the reaction. So this is 8 mark sign. So are you ready for the example? We proceed. So this is an example, balancing acidic media. So we are going to end on this point. Yeah, so that you guys, you can go and dream about your dreams. Yeah. So we start, right? We start. So this is the question we have here. So we need to balance this reaction. So let's go. Let's begin. Solutions. So solutions, we start. Number 1, we said that we have to assign oxidation numbers of all the elements except hydrogen and oxygen here. So in this one, we have these guys here. We have got MnO4 minus plus, which is iodine ion. We are getting MnO2 plus I2. Okay. So here we need to assign for manganese, iodine, and iodine here. Because these are uncommon elements. But for oxygen, we can't assign because, and then hydrogen, we don't have it. So we can't even think about it for now. So in here, let's check for this one here, MO4 minus. So same thing we are from doing. So, this one will be Mn plus 4 oxygens, the overall charge is -1. Okay, so what is next here is that Mn plus 4. What's the oxidation number for oxygen? We know that it's -2. So it's the importance of what we did, the steps from there, because it's helping us here. Then the total charge is -1. So meaning manganese is -8 equal to -1. So meaning manganese will be basically -1 plus 8, which is the manganese is +7. So I've calculated, meaning you get the 1 mark here in the exam. Then now we come to this one here, iodine. So remember what I told you, that when an element is standing alone, like an ion, say an ion or a compound, the charge indicated on top is always equivalent to its oxidation number. So if we check here, iodine, we have a -1 on top, meaning this one is already direct, -1. Don't need to panic about it. So same applies even when it comes to this one here. So I mean, to the reactant side we are done. Now we go to the product side. So the product side, we have got this guy here again, iodine. We don't have any charge on top, meaning it's a 0, right? Because we don't have anything on top there. Now we come to here where we need to calculate. We come for the manganese 2 oxide here. So overall charge, we don't have anything, meaning it's a 0, right? So what we do is that we say manganese plus 2 oxygen, overall charge should be a 0. So if we were to calculate, we are going to say that manganese plus 2 and then -2 is equal to 0. So manganese minus 4 equal to 0, meaning manganese in this case is +4. Okay, so we have calculated everything, all oxidation, meaning step 1 we are done. The one we say assign oxidation numbers of all the elements except oxygen and hydrogen. So now let me just rewrite this into something that you can see properly. So what we have is that we have okay, plus okay, so we say here we calculated it was +7. Okay, then this one is -1. Then this one is +4. Then this one is 0. Okay, yeah. Now we are going to bring it down here. We say we have got this one 4 minus plus iodine minus, we are getting then plus that. So we know that this is +7, this is -1, this is +4, this is 0. So we know that this one is containing manganese, meaning it has to be like with this one, iodide with iodine. So now I'm going to do this, kama arrow, you try to compare now. We need to split this step 2 to identify which one is the reduction, which one is the oxidation of reaction. So we compare how was this compound was initially before the reaction and how it has become. Again, we check this one, how it was and how it has become. So we check that initially before the reaction, the oxidation number for manganese was +7, but after the reaction, it has become +4. So do you think there is an increase in oxidation number or decrease in the oxidation number of manganese? So can someone type up first? Before the reaction, manganese oxidation number was +7. Then after the reaction, it has become +4. Now, is there an increase or decrease in oxidation number? A decrease or increase? First, so that we can move. Is there an increase or decrease in the oxidation number of manganese? Okay, so good. There is a decrease in the oxidation number. So meaning that remember what we said. We said that a decrease in oxidation number is called reduction of reaction, meaning that this one is a reduction of reaction. So we can basically say that this is now our reduction of reaction. Again, we come here. Iodine, it was -1 initially, it has gone to 0. So even if we were to draw a number line here, for example, this is 0. If you are here per -1, then we have moved from -1 to 0. Is there an improvement or what? Someone was with a -1, then has gone to 0. Is there an increase or decrease? There is from -1 to 0. Are we increasing in our values or we are decreasing in this case? So from -1 to 0, is there an increase in oxidation number or decrease for this one? So this one is correct. Very good. Pacheko, Chichi. Okay, now here we come for this one, for the other guy on top there. Is there an increase or decrease from -1 to 0? And we have to be typing fast. We have to finish so soon so that we go sleep. So here there is an increase because -1 and 0. 0 is better than negative, right? Yeah. So this one will be called oxidation of reaction. So meaning we have identified which one is yeah. So this is how we calculate. We assign oxidation numbers. Step 2, we identify which one is oxidation of reaction, which one is a reduction of reaction. So after this, we need to split the two of reaction. So we need to split them. We say that this side we are going to have our we can start with N. So for me, I will say, okay, I have my oxidation of reaction. Then this side I've got my what is reduction, okay. Of reaction. So our oxidation of reaction, the one on top where we have iodine producing iodide 2. Then the other one is where we have manganese O4 minus producing this guy here. So this is our reduction of reaction, oxidation of reaction. So what we have done so far is that we have calculated, we have assigned oxidation numbers. After that, we have identified which one is the reduction of reaction, which one is the oxidation of reaction. After that, we have now splitted the two of reaction, separating them so that the first reaction only contains oxidation things, the other reaction contains things to do with reduction. So we have splitted the two. So this is what we do. So after this, we know that now we have to balance all the elements except what? Hydrogen and oxygen. You remember that step? So let's move to the next step that you need to know. So next step is that we already have this. So I'm going to repeat say ox. So I'll say oxidation of reaction, which is I. Just use the blue pen here. Minus to I2. Then we also have the reduction. This side, which is M. NO4 getting M. NO2. So I'm saying that you have to balance all the elements except oxygen and hydrogen. So if you check, How many iodine are here? 1. How many are this side? 2. So we can put a 2 to balance this. We don't care because we don't have oxygen, hydrogen. Just let it be like that, okay? Then we come here. Manganese 1, manganese 1. Oxygen here we have 2, oxygen here I've got 4. But we don't balance oxygen using numbers. We use water molecule. You remember that. So we are not going to balance anything here. So let me just swap this so that it looks nice. So reduction will come here so that we create space, which is M N O4 minus. We are getting M N O2. Then for the oxidation, so I've just swapped the 2 so that we create space. Which have I minus, we are getting that is the I2. So we put a 2 there to balance it. Okay. So now let's go to the other step. So we have done step 1 to assign oxidation number. We have done step 2 to identify which one is the reduction, which one is the oxidation. We have done step 3 where we split the 2. Now we have also balanced. So now after this, we have to balance oxygen using water. So now let's balance oxygen. Since we have oxygen here, we need to balance it. So we have 4 oxygen here and 2 oxygen here. So to the reactant side, we have more oxygen. To the product side, we have less oxygen. And we know that we need 2 more oxygen here to become 4,4. So we know that in water molecules, how many oxygen are here? How many oxygens are present in water molecules? So it's 1 oxygen, right? So to get 4 oxygen here, we need to add 2 water molecules so that we get 2 oxygen in water molecule plus these 2 to get 4. So meaning this one will be balanced as NO4 minus, getting this is NO2 plus 2H2O. This side we don't have anything, water, whatever, so we can't balance what we don't have. So reactant side and product side don't have the oxygen and all that, so we leave it like that. But where we had the problem was here. Okay, so now we have 4 oxygen here plus 2 oxygen here, which is for meaning oxygen is balanced. But we should know that the time we are balancing the oxygen, we have created a problem. We introduced hydrogen, which we never had initially, and 4 of them. Then this side we don't have any hydrogen, and we said that to balance hydrogen, we use hydrogen ion, which is appropriate number of hydrogen ion. So we are going to add 4 hydrogen to this side so that they can also become 4. So we're going to say that 4 hydrogen ion plus MnO4 minus, we are getting MnO2 plus 2H2O. Then this will remain the same. Nothing will change for this one. Yeah, so this is what we have now. So if you check it out, we have 4 hydrogen here, 4 hydrogen here, 1 manganese, 1 manganese, 4 oxygen, 4 oxygen. In this case, we don't have any problem. 2 iodine and 2 iodine. That's okay. So after this now, we have to move to the next concept. We need now to calculate the number of electrons that was gained. This is a reduction of reaction. So how many electrons was gained here and how many was lost here? So how do you do that? We are going to rewrite this as we have got 4, that one plus okay, minus on top there, then MnO2 plus 2H2O. Yeah. Even here we do the same, we have that, and then we are getting HI2. So we said that this one was positive 7 and it changed to positive 4. So you have to compare. Positive 7 to 4. How many electrons have we lost here? So 7 to 4. Just subtract it to the difference in the number of electrons gained. So 7 minus 4, the answer is 3. So meaning 3, and it's a reduction of reaction. 3 electron was gained. And since the reduction, where do you put electrons? To the reactant side. So we have got 3 electrons that was gained. And since we only have 1 manganese, so we have 3 electrons, just that. So these electrons are from the reduction of reaction. So they should go to the reactant side. So updating the equation, we're going now to add the 3 electrons. We're going to get 4 hydrogen ion plus this one here, permanganate, then plus the electrons, 3 electrons that was gained. It's reduction to the reactant side. This will give us MnO2 plus 2H2O. Okay. So meaning we have calculated how many electrons was gained and we have added to the reactant side. Now we come here. How many electrons was lost? This is oxidation. It is associated with loss of electrons. So how many electrons was lost here? Remember before the reaction what we had for this one? Why that paper? Yeah, it was -1, then it moved to 0. Okay. So we have again to subtract. What is 0 minus 1? Or -1 plus minus 0? The answer is just -1. But we don't write as a negative, so we write it as positive 1 electron. So we don't put a negative to number of electrons. So electron now is positive. So even if when we subtract it to give you a negative, just make it positive 1. Yeah. So positive 1. Then because this one is the oxidation of reaction, where do you put electrons? To the product side. Meaning if we update this reaction, we are going to get 2I minus, we are getting that one. Okay, yeah. Before we even proceed here, one thing you should understand is that in this reaction, how many iodine do we have? We have 2 iodines, 2 iodines. So meaning this 1 electron, the number of electron lost by 1 iodine. Now that we have 2, so we have to multiply number of electron that we have gotten here times the number of element that we have. So 1 times 2, we get 2 electrons. So we're going to add 2 electrons here. We have multiplied 1 electron lost by 1 element multiplied by the number of elements. So elements are 2. So be 1 multiplied by 2, we get a 2 here. In case here it was 7 minus 4, get a 3. 3 multiplied by 1 manganese, we just get a 3. No wonder we added a 3 direct. But in this case, we have got a different case. We have 1 element electron initially, which was lost. But we have 2 iodine, meaning each iodine was able to lose 1 electron. Now they are 2. So be 1 times 2. We get a 2. If they are 4, say 1 times 4, we get 4. If they are 100, say 1 times 100, it be 100. Just that's it. Depending how many they are, we multiply and get the answer from that. Okay, so now let's proceed to rewrite the equation in the next step. So we have reduction here, and you have oxidation this side. So our reduction is simple. It's that 4 hydrogen ion plus manganese O4 minus, and then plus 3 electrons. Is this how it works? Okay, yeah. 3 electrons, we are getting something here. It's giving us manganese O2 plus 2H2O, like this. Yeah, like that. Then, in the case of this other reaction, it is 2 iodined. We are getting iodined 2 plus 2 electrons. Okay. So what have we balanced so far? We assigned the oxidation numbers. We identified the reduction and the oxidation half reaction. We splitted the reaction into 2 half reactions. After that, we balanced all the elements. We balanced hydrogen. We balanced oxygen. We also have calculated the electron that was lost and gained. So that's where we are now. Now, there's one important concept that we need to know, is that between the 2 half reactions, this number of electrons should be the same. So in the reduction half reaction and the oxidation half reaction, the number of electrons should be the same. So if these are not the same, always make them look same. So we know that how we do that, meaning number of electrons here is going to multiply this reaction. The number of electrons here is going to multiply this reaction, that we achieve that. So meaning 2 will multiply this reaction, 3 will multiply this reaction, so that we can get equal number of electrons. And then that multiplication will affect everything, this reaction, even here same. So what I'm saying is, we are going to say number of electrons here, which is 2, will multiply this entire reaction. The reason why we are doing this, we are trying to achieve number of electrons. So in case when you are solving an exam, and then these electrons are the same, don't do that, because it's already the same. But if they are not the same, now we have to achieve the principle to make sure that they are the same. So 2 should multiply this reaction, 3 should multiply this reaction. Okay, so we're going to have 2 multiplied by this whole thing, which is 4 hydrogen ion plus MO, 4 minus, by 3 electrons. Then we are getting NO2 plus 2H2. Okay. So we say, what is 2 multiplied by 4 hydrogen ion? We get 8 hydrogen ion. Then 2 multiplied by that, we get plus 2. That 2, and then 3 multiplied by 2, we get 6 electrons. Again, 2 multiplied by this, we get 2M NO2. And then 2 multiplied by that, we get plus 4 water molecules. So meaning this is now our new reduction. Okay, now we come to this one here, where we have this guy here, where we are getting it is 2H, where we are getting I. So the number of electrons, which was 3, should multiply this whole thing. So this was multiplied by 3. So what is 3 multiplied by that? We get 6 iodined. This will also be 3I2, then plus 6 electrons. So meaning this is also our new oxidation. Okay. So we say we have 6 electrons here, also 6, meaning we have achieved our principle that we are looking for. Okay. So in this case, we can rewrite everything now. So we have reduction here. Our reduction of reaction is 8 hydrogen ion plus 4, plus 3 Okay, sorry. This is 8 hydrogen ion plus 2M NO4 minus plus 6 electrons. Then this will be producing 2 manganese O2 plus 4 water molecules. Then our oxidation next after that, let's look for our oxidation of reaction. So now oxidation is that we have got 6 iodine, then this is giving us 3 and then I2 plus what? 6 electrons. So I can see that we have balanced everything. So if you check it out here, manganese we have 2, balanced, right? Hydrogen ion we have 8 here, 4 times 2, 8 here, balanced. Oxygen we have got 4 here, 2 times 4, this is 80. Even here have 4, this is 2 times 2, 2 times 2 get 4 here, plus 4 which is 8, balanced. Electron 6, okay. So here everything is okay. We come here, 6 iodine, this 3 times 2, 6 electrons. Electron here balanced, electron here balanced. Meaning now everything is balanced. So when we balance everything, now we go to the final step where we have to add now the 2 half reactions back. We splitted, now we have to add. So the way we add is simple. Reactant in this one plus reactant here. Okay, so we are going to do that by adding the 2. So I'm going to say reactant here plus reactant here. We can start with any, either this one plus that, whatever you think is okay with you. So I'm going to add now. We say we add, final step, add the 2 half reactions. So it will be 8 hydrogen ion plus 2 minus plus 6 electrons, then plus this one here plus 6 what? 6 iodine. So we have added this one plus this. This should give us the product there. Well, we have 2M NO2, then plus 4H2, yeah, then plus this one what we have here, plus 3 I2. So I'm going to write electron down here so that you see them, because there is no space here, plus 6 electrons, yeah. So we have added back the 2 half reaction, meaning we add reactant plus reactant, we write here. Product plus product, we write there. So after this now, we have to cancel what is common. So if you check, we have 6 electrons here and 6 electrons there. Then anything else common? I don't think we have any. We have hydrogen ion, we don't have any there. We have water here, we don't have anything. So this one is not common. This is 2. Here we have got a 4 and a charge. Nothing is common. So at this point, I don't see anything. So sorry, we cancelled. This has to be cancelled. So this should remain. So I made a mistake here cancelling this one instead of electrons. So this is remaining. So nothing else is common at this moment. Only electrons was common. But in some cases, we find that even water is to both sides. So we can have 4 water molecules here, meaning 8 here. So the smaller should go, then the bigger has to be reduced. So at this moment, we can now rewrite our reaction that this is now 8 hydrogen ion plus 2 MO4, then plus 6 I minus, it giving us 2 MO2 plus 4H2, then plus 3I2. So now we have to confirm if everything is okay. 8 hydrogen, 4 times 2, 8 hydrogen. 2 manganese, 2 manganese. 8 oxygen, 4 here plus these 2 plus 4 here, 8 oxygen, all right. 6 iodine, 6 iodine. We don't have electron, so electron should never be there. So now, the presence of hydrogen ion, remember what I said, an acid is a reaction that produces hydrogen ion as the only positively charged when dissolved in water. And we have hydrogen ion here, and everything is balanced. So if you want now, we can put that symbol. This is aqueous. This also have to be aqueous, and then solid, liquid, and then okay, solid, yeah, like that. So meaning we are done. So this is, we are done in acidic medium. So we are done in acidic medium. So what's remaining now is basic medium. But you let me know if we can proceed. So I want we take a break for now. We stop from there, from here. Then if at all in the morning, around 6, we are going to have around 6 hours, yes? We need to have a class where we have to conclude now about basic medium. Okay, so for today we can end here. So what we do is that we have to watch the video so that we understand. I think I've seen a certain question here. Let me just check. Why are we cancelled 6 on? Oh, sorry. So the one asking why we can't this one, I made a mistake. We don't need to cancel this. So I was supposed to cancel 6 electrons and 6 electrons, but I made a mistake cancelling 6 iodine. So know that it was just an error. I cancelled a wrong item. Yeah. So we don't need to cancel it because we don't have anything to cancel with to the other side. So let me know. Can we have a break now and do the redox, the basic medium today? Or we can have a class early in the morning around 6, maybe 6:30 to 7 hours will be done from there, or 6 hours to 6:30. Because acidic medium, basic medium is very simple. It's only about 2-3 steps from here, which we are done. So this is how we do it. Basically, we'll just have it tomorrow morning here. So what we do, go through watch the video, and then go to the website and start that document. The document is named what is it's basically Aqueous solution, yeah. Aqueous solution part 2. So go through the document, Aqueous solution part 2 from the website there, and also watch the video and get the base concept. Tomorrow morning we are going to do the remaining parts so that we can be set for this one. In case you want to join us, you can text me on this number 499. If you want to be part of the web, to be added to the website where we can get access to the notes in biology, physics, chemistry, and math, just text me WhatsApp and then we can talk from there. I can add you to the website. So for today, we can end here, and maybe if someone have got the question. So we continue today. Okay, let's end from here and then we are going to restart. Yeah. So we can end from here and then we can start after this.